This is a quick little video here. They're mentioning temperature conversions. It says Fahrenheit is rarely used in chemistry. Guess what? We will never use Fahrenheit. You'll find that if we're using a digital thermometer, there's a button on the back that toggles between Celsius and Fahrenheit. If you are ever getting readings of hot water being 200 degrees Fahrenheit, you need to switch that to Celsius unless you really want to do the math. We will never, ever, ever measure in Fahrenheit. Now, we will use Kelvin from time to time. The Celsius scale was designed with 0 being the freezing point of water. The Kelvin scale was designed with 0 being this theoretical coldest temperature possible, this absolute 0 value, which ends up being about negative 273 degrees Celsius. And we'll talk more about Celsius and Kelvins later, especially when we get into thermochem and some of that fun stuff. But we will never use Fahrenheit. So you don't have to worry about this funky switch from Celsius to Fahrenheit. The only temperature conversion we will ever use is Celsius to Kelvin. And in fact, it's given to you on the AP test. So you don't have to memorize this switch between Celsius and Kelvin. They will give it to you. So down at the bottom, it kind of tells me here that if you want to switch between Celsius, we're thinking about it, degrees Celsius and Kelvin, you can just add 273, get you 2 Kelvin, and then obviously if you're at Kelvin, you just subtract 273, and that gets you back to degrees Celsius. Notice also that there is no degree symbol in front of the Kelvin. If you do put degrees Kelvin, I'll just cross it off, but that is not necessary, just with Celsius or Fahrenheit, and we'll never use Fahrenheit. But this is a conversion that is given to you in the AP packet, but I promise you will use it. So we should make note of that, a temperature conversion. And the other little calculation that they want you to be familiar with here is density. Yes, we will use density. Density could pop up in so many different places. It could pop up in solutions, in stoichiometry. It could be a situation where, I'm given the density and the volume, and I need to figure out the mass of this liquid or whatever it might be in order to do some stoichiometry. So having the density could be something that we'll need to put to use. I would obviously know the general equation. This is not given to you in the AP packet. Density is mass over volume. They expect that you know that. An unknown substance has a mass, of 19.625 grams and a volume of 25.00 cubic centimeters. What is the density of this unknown substance? We were talking about this in a prior video, how sometimes people look at this and they're like, oh, Lord, this is so easy. Density is mass over volume. And so they'll take that mass, 19.625 grams, divided by volume, 25.00, and they'll say 0.0 nothing. So they'll just put it in their math as 25. That's going to lose you half a point. That's not good. I mean, it's something super easy to fix. If they listed it as 25.00, there's a reason. They want you to use it. 25.00 cubic centimeters. Whatever I was measuring with allowed me to measure for sure 25.0, and we're going to estimate 0.00. Use those zeros. Use them in your work, and then obviously we're going to need them when we do our final rounding. So don't drop those too quickly. That's kind of another rookie mistake that loses you a quick half point, and then I'll feel really bad because that would have been very avoidable. So we plug this in our calculator. It's a division. My mass is in 1, 2, 3, 4, 5 sig figs. Sig figs. My volume has 4. There are zeros at the end of the number, and yes, there is a decimal spot. 4 sig figs. So I plug this in my calculator. I'm going to round this off to the first 4 digits. 0.7850. And I do have to be careful with my units. Grams per cubic centimeter. If you would have listed this as grams per milliliter, that would be acceptable, because a cubic centimeter and a milliliter are equivalent. But I typically go with the units that are given within the problem. So if it lists grams per cubic centimeter, I'm going there. So the density equation is something that I should be able to solve for any variable. It is common that I might have density in a volume or density in a mass, and I need to solve for the missing variable. So I should be able to manipulate this for any variable. I should be able to solve it for sig figs and proper units.